Lindsay has to take off. Let's get our room rearranged. We will be guided by Mr. G. He's going to show us where to go.
Alright, we're going to go back to the way you guys were when I first came, the 4 groups of 4. Alright, so when you hear, you can just bring your desks over and I'll tell you how to arrange them when you get over. So over here, let's see, Connor, Bryn, Cam, and Brad.
That's a good place to start.
Okay? You guys can start moving your desks once you hear your names. And then over here, Will, Eli, Andrew, Ashley. Over here, Oliver, Liam, Braden, and Sarah. Finally, Lindsay, Sam, Jody, and Alex. If you didn't hear your name, raise your hand and I'll tell you where to go.
Every owl head.
So, I want...
So that Lindsay's not so bad. Except you need to push back. Hey, I was
Go over the spiral answers. If you didn't finish, just follow along. Yep, spiral's open. If you finished early, make sure you take them out. Liam, you ready? Alright, number 1. Which number comes next in the pattern? Who wants to come up to the board and show how you did this? Got it? Alright, come on. Can you explain the pattern to us when you do it?
So I figured out, when I looked at it, I figured out that, so I figured out that we're subtracting and that 121
Can you show it? Can you write that like a little loop? And you don't have to show them that, but just like this, it's showing from here to here. What did you subtract?
On mine, you subtract 12.
Okay.
And then from here to here, you minus 10. And then here, from here you minus 8. So I figured out that I would have to subtract 91 minus 6 because every time you minus, like, you subtract 2 from the other number.
So it's 2 less than the
Yeah, 2
previous
less
time.
than
Yep.
And then this one would be. So it would be 85.
Who got 85? That is the right answer. Good job. Okay, the first part is finding out the pattern, then just carrying it over to the next step. So 85. Number 2. Estimate the sum 7 1/4 plus 2 5/8. Ashley? Good. How did you do it?
I estimate 7 to 7 and 2 5/8 to 0. And 3.
3. Yep. 7 plus 3 is 10. Good. Any questions on that? Estimating? You guys are used to that now, right? All right. Number 3. Find the difference of 3/4 minus 5/8. Really? You want to come up and do it on the board?
What I did first was I found the denominator for 24, right? So that would be greater than 8. And then I added 2 to this.
Added 2 to that? Or
Multiply 2 to this.
right, so if you're finding the common denominator, you have to multiply the numerator and denominator by the same number. Four goes into 8 how many times? Very good. 1/8. Everyone got that? Can you read the question?
How many different 3-digit combinations can be made using the digits 1, 6, and 9 if no digit can be repeated?
And you want to tell what you got for that?
I got 6.
You got 6. What were your different numbers, or did you just write 6?
1, 6, and 9, 1, 9, 6, 9, 1, 6, 9, 6, 1, 6, 1, 9, 6, 9, 1.
But what if it said that the numbers can't be repeated?
Right, that means we can't have a number like 111, 666, or 999, right?
Or 9, 6.
Each number can only appear in the combination one time. So the answer was 6. Okay, you start by putting the 1 first, and then switching to 2 numbers after that, and then putting the 6 first and switching to 2 numbers, and then the 9 first and switching to 2 numbers, and you'll get 6 combinations. Any questions? Okay. The last one. How name the vertices? First of all, who can give the definition of vertices? What are vertices? What? Yeah, it can be corners. It doesn't. Does it have to be top? Ah, yeah, that would be a vertice. So it's anywhere where 2 or more lines meet, and that usually makes a point of some kind, right? Like it could be a corner like this, or it could even be like this, like a shallow angle. Okay, but those are vertices. And if you look in if you wanted to find the definition in your math book, where did you have to look up in the glossary? Did you find vertices? What word would you find? Vertex, right? That's one. Vertices means more than one. So you'd have to look for vertex. Okay? So what were the names of those? Liam?
H, F, F, D, B, C, C, D, A, H, A, G, F, G, B, C.
So you actually named the lines, right? A line would have two letters because Liam, think like one end has one letter and the other end has another letter. Okay? So those are the names of the lines. The names of the vertices are actually just the letters themselves. So A, B, C, D, E, F, G, and H. Those are all vertices.
So just list all the letters.
Just list all the letters, because if you look at the picture, there's a letter at each corner where 3 lines meet. And those are the vertices. Okay? Any questions about that? So before Catholic Schools Week, what was the main idea of our math lessons? What were we working with? What kind of operations and what kind of numbers? Fractions. And what were we doing with them? Before Catholic Schools Week, we were dividing? Multiplying. So, before we get to the new lesson, let's make sure we remember how to multiply fractions. So let's do Alright, so who can explain what's the first thing you want to do when you multiply fractions? Ashton? Cross simplify. So can we do cross simplifying once, or can we do it twice, or can we do it 2 times, or can we do it no times?
As many times as.
So if we can do it twice, then we can do it twice. But what if we can only do it once? Does that mean we can't do any cross simplifying? No, so before break, or before Catholic Schools Week, some of you had the idea if you can't do it both ways, then you can't do it at all. But that's not true. If you can do it just one way, go ahead and do it. You don't need to do it both ways. Right? You can do it none, you can do it once, or you can do it twice. Whatever's going to make it easier to simplify the fraction. So go ahead, who wants to give me a hand? Huh? You can just tell me what to do.
Okay, you can cross simplify 3 to 1.
Yeah, so which numbers are you cross
3
simplifying?
and 30.
3 and 30. So 3 would be 1.
And then 30 to 10.
Good.
And then for 24 and 8, 24 would be 3.
24 would be, okay, so start with the lower one, right?
8 would be 1.
Because 8 goes into 8 once.
And 24 would be 3.
Because 8 goes into 24 3 times. Any questions on this part? Cross simplifying. No? All right then, Andrew, what's the next step?
Then you multiply the numerators and denominators. So
What, can you say that again?
you multiply the numerator to numerator and denominator to denominator.
Numerator times
Yeah,
numerator, right?
numerator times
Good. So numerator 1 times numerator 3 is 3.
1 times 10 is 10.
Can you say it though? Say the trick, because this is important for moving on to the next lesson. What's this?
1.
Well, what is it though? This is the
Oh, denominator
denominator times
times
denominator. Is?
10.
Good. Are there any more steps now? 3/10. Can I leave my answer like that? Can I simplify it? Can I make it back into a mixed number? Not this one. So this is our final answer. 3/10. Any questions? Speak now, because after we move on to, now we're going to move on to dividing, it's going to be a little bit trickier. So make sure you understand this. All right, let's go on to the new lesson, which is dividing fractions. So who wants to read that example A word problem first? Go ahead, Brandon.
Mr. Wagner makes wooden coasters for glasses. He cuts small round posts into 1/2 inch thick slices. How many slices can we get from a 5-inch post?
Good, so he has one 5-inch piece, but he wants to break it up into 1/2-inch pieces. What's over there? you look over either this way or this way, please? Turn your bucket this way. He has one 5-inch piece and he wants to break it up into half-inch pieces. So is that going to be a multiplying problem?
Right.
We're dividing, right? We're breaking it up into smaller pieces, which is dividing, right? All right, so what are our fractions going to be? What are we going to divide? Over? Oh, first, just it's one 5-inch piece, so don't, I mean, usually when we write 5-inch piece, it's just going to be 5, right? 5 divided by half. All right. Do we know how to do this yet? Did we learn how to do this yet in class?
No.
So, Kim, would I just simply... So, want to tell me the first step? What do you think I want to do first? But this isn't minus, this is divided by. Have we learned dividing fractions yet? No. So, any ideas for the first step? I'll give you a hint. It's the first thing that we do when we multiply fractions. When one number is a whole number, what do we want to do, Ashley?
Put a 1 under it.
Put the whole number over 1. Okay, now we have 2 fractions. One improper fraction and another fraction. But we still have divided by. So can I do the same trick, numerator times numerator? Well, that would be multiplying, right? Numerator times, it doesn't work. So I need a trick. I need to try and make this into something you know how to do. Oliver, I know I already told you, you already read the trick, but I want everyone to see it really clearly. So hands down for a minute, okay? There's 3 steps that you want to do, okay? The first one, this part, I want you to remember, you want to say, stay. What do you think stay means?
Oh, because that stays how it is.
It stays how it is. Everyone say stay.
Stay.
The first fraction, you keep the same, stay, right? The next step, we want to change our sign. Good. I already asked you once, please come this way. I want to change my sign. Now, what sign would we know how to do if we had in the middle here? We don't know how to divide, but what do we know how to do? Multiply, okay? So I'm going to change my sign. Okay, so step 2 is change. Step 1 was stay. Step 2, change. And step 3, everyone say flip. So what do you think I'm going to do to my second fraction? Right?
Switch the numerator and denominator.
Switch the numerator and denominator. We're going to flip these, okay? Look a little confusing? Yeah?
Kind of.
So, let me write my third step. So Luke, can you see where I stayed? What does stay mean? What part of the problem did I stay? 5 over 1, which is the first what? Not because it's an improper fraction. Even if it was a regular fraction, you would still stay. The rule is the first fraction, whatever it is, it stays. You don't touch it. You don't change it. You don't flip it. You don't multiply it. Nothing. Stay. Just like you, stay. Okay. That was step 1. Step 2, change. What did we change, Cam? We changed the dividing sign to right here, multiply. Okay? And step 3, Liam?
Flip it. But
Flip what?
the numerator and denominator.
Of where though? Where did I do that?
Fraction.
Yeah, which fraction?
Fraction that you're dividing by.
Yeah, okay, that's one way to put it. But the second fraction, okay, this fraction, the one on the right, the one on the end, okay? You don't want to flip this one, okay? The first one stays, the second one flips. So, I'm going to rewrite this 5 times a half. Okay. What's the first thing we did? Ready?
Well, put the 5 over the 1.
Good. That's not part of the dividing fraction. This is something we did when we did multiplying too, okay? Now we can work with, okay. Now we can do the 3 steps that I just explained. So what was the first step? Jody, do you remember? Stay. So what does that mean? Which one am I working with when I say stay? This one, right? 5 over 1, that stays. Okay. Step 2.
Change.
Well,
Change
change what? So what am I going to change?
the division symbol to a multiplication.
Perfect. Now we have 5 over 1 times something, but step 3 said I have to flip. Can you come show me how to flip it? Okay, go ahead and erase it now and write it out usually. There we go. So now instead of a half, we have 2 over 1, which is 2, right? Any idea what this is called when we change the numerator and denominator? Your book has some new vocabulary word. Oliver, what is it?
I'm not sure if I can pronounce it.
That's okay, give it a try.
Reciprocal.
Perfect. Everyone say reciprocal.
Reciprocal.
Reciprocals are any numbers where the denominator and the numerator are just flipped. Okay, so what's the reciprocal of 3/4? Everyone.
4/3.
4/3. Okay, the reciprocal of 25/100.
125th.
125th. Okay, so this idea of reciprocal is something you need to know when you're dividing fractions because you have to find the reciprocal of the second one. Okay, that's the flip part. Okay? The easy way to remember it is flip, but the real thing you're doing is making the reciprocal.
So
Question.
when you so basically reciprocal means flip. You have to flip this number, but that's just more of like the math word.
Yeah, exactly. Yep. It's when you flip a fraction so that the numerator becomes the denominator and the denominator becomes the numerator. So if it was improper before and I find the reciprocal, then it will be a regular fraction. But if it was a regular number before and I flip it, now it's a improper fraction. Good observation. All right. Any questions? We're going to go on to the next. Oh, yeah.
I have a question. How would you flip like hold up.
Okay, let's look at it. So like if we have 3/4 divided by 10, like that. Any ideas? Well, what's the first step? Before we get to our 3 steps for dividing, what's the first thing we always do? Yeah, make this into a fraction, an improper fraction, but it's still a fraction, right? So what would be the method now? Stay, change, and flip this. So now instead of this being 10, this would be 1/10. Okay, so this would be now 3/4 times 1/10. Do you know how to do that now? Okay, so we got to this step, right? So now that we stayed, changed, flipped, what do we do now? This is what we did before Catholic Schools Week. What do we do? Andrew said it before. What's the method? No. So now we have a multiplication problem. So you explained this before, Andrew.
Oh yeah. Numerator times numerator.
Numerator times numerator, which is 10.
And then denominator times denominator.
So what's our answer? 10 over 1, which is 10. Okay? Question?
When we were flipping the dividing to the multiplying for the last problem,
On which problem?
that one.
Yeah, this is the same as this one. But
Yeah.
okay, I'll yeah. What do you-
So if you're like if they put in like a multiplying one, like a multiplying one symbol, would you flip that to a dividing symbol?
No, because we already learned multiplying fractions, right? So the only reason we're changing this division is because we want to make it easier to do something you already know how to do. So if you had a multiplication problem and you wanted to change it, you could change it to a division problem, but then you'd have the same problem. If you don't know how to do the division, you would just want to flip it back again anyways, right? So the goal is to get something you know how to do by changing to a multiplication problem. Because we already know how to do numerator times numerator, denominator times denominator. Understand? Yeah?
Good question, Sam.
Was a good question, yeah. I guess the answer is you don't want to make it harder for yourself, right? Okay. Any other questions? I'm going to assign the homework and you guys can work on it for a few minutes, but make sure you ask questions now. No questions? All right, homework.
And as you start your homework, does that mean you cannot ask questions? You have to do it completely solo? No, you can ask questions, okay? If you get to one you're not sure of, make sure you ask so that if you get to others later on, you'll know how to do it.
Okay, we're doing on the next page, page 268, number 10 through 29, and 32 to 34.